Okay. Magigutom na siya kung sigyaw-yaw guys. Uy. Nakakaloka. Diba? Hey, shout out mga kapatid, Ma'am Tanyang Wegas and Jonathan Agrao. Oh, diba? Bulletproof. Kung saan siya? Uy, bulletproof. Thank you kayo, bulletproof. Ma'am Grethel Bacal. So, Teacher Grethel, Pearl Agate. Thank you so much for watching this live streaming, simultaneous YT and FB live streaming. Okay, guys? Ganon. So, muna siya. Sugod na ba ako, guys? Masa man to? Density and pressure. Okay. So, basic really, guys. Okay. Pressure and density. Okay. Let's talk about pressure first because pressure is very important. We need to take our blood pressure. Right? So, that's one requirement for our health data to become healthy. We need to maintain the pressure of our blood. The unit for that is millimeters mercury. Okay, so I will illustrate first, or I will elucidate first. I will I will emphasize first the values of the pressure before anything else, before going to the problem solving. Okay, 1 atmosphere, so that it's transparent. You know already the different kinds of unit of the measurements of the pressure. It's not enough to memorize only one unit. You should memorize all. Wow, all talaga. Okay, 1 atmosphere is equals to 760 mmHg. Okay, and it's also equal to 760 torr. Okay, it's also equal to 1.013 bar. Okay, not 1. It will matter the point something, especially if you use the gauge pressure in different vessels, process vessels, in different processes and industries, okay? Usually expressed in gauge pressure through the, the device attached on the tank, attached on the vessel, attached on the pipeline, something chuba-chucho. Ganon. So 1.03 bar. Okay. 1 atmosphere is equals to 14.7 psi, meaning pound per square inch. Okay. PSI, mean English unit of pressure. So pound per square inch. Inch raised to the power 2, right? Because it's square. Now, this pound, guys, is also known as a pound force. But we will just say that a pound because it doesn't matter at all. But to be specific and precise, that is pound force. Okay, like the LB small f over square inch. Okay, something like that. But this is okay. But in the calculations, it matters because you will be engaging with the Newton, the unit of force, din problem. If you don't know, Newton, kilogram meter per second, nga. Kinabi kay force diri ari sa gitupat nimo sa pound. And during conversion, makakabaw, na pound force din na siya, uyabo. So you should memorize and understand that that is really technically pound force. But generally speaking, it will be just pound per square inch for the purpose of generalities. Okay, that everybody can understand, not only engineers. Okay, you got the point. But technically, that is pound force, English unit of pressure, PSI. Ganon. Now, 1 atmosphere is equals to, okay, 101,325 Pascal. Okay. Okay. These units, guys, memorize this when you are still in the lower level. So that in going to second year, third year, fourth year, fifth year, oh, master na kay kaning higayon na. Then during problem solving, so it's easy for you to, to manipulate. And it's easy for you to pass the board examination. Not really it's easy, it's comfortable for you to be confident to pass in the board examination. Okay? Because you have the basics, the standards, the formulas like that. Memorize that while you are still in the first year level or even in high school for the basic concepts in chemistry and physics, right? Okay, so 101,325 Pascal is equal to 1 atmosphere, or is equal to 1.013 kilopascal. Just move that with 3 0. 1, 2, 3. So 101.325 kilopascal. This Pascal or kilopascal chuba chuchu is very easy. Moving only 3 zeros. because that is kilo. Kilo meaning prefixes in algebra. Okay, 10 raised to the power 3, positive 3. And then the negative part in the prefix of algebra, that is 10 raised to the power negative 3. That is milli. That's why I always emphasize, guys, to help you to memorize all the prefixes starting at your young age, from 10 to the 1 to the 10 to the 18. If you want to become really engineers in the future, memorize all the prefixes, okay? So that there's no escape during the conversion of the problem solving, something like that. And then 10 to the negative 1 to 10 to negative 18. Oh, ganon, di ba? Special. Okay, now, we have the units of pressure all about this. So there are at least 1, 2, 3, 4, 5, 6, 7. There are 7 units of pressure, and memorize that as early as now. Okay? If your course is related to science or engineering course. Okay? It's always like that. Okay? If you make a bridge, pressure is very important. Okay? You need to overcome the pressure that those vehicles will pass on the bridge. Right? So it's very important, and you need to determine the centroid pressure also, the center of gravity of your structures when you build a bridge, a house, a school, or name it, whatever infrastructures you have. The concept of pressures are very, very, very important, guys. It's part of the design, operating parameters or operating conditions. Another unit for this is through the formula. Because this is basing on the standard pressure. We have also another pressure that's based on the formulation. We have the pressure is equals to the density, the density times the height. This is also a pressure. And we have also the pressure na katong sikat. Pressure is equals to the applied force perpendicular to the surface area. So this is force over area. This comes in the Pascal, because the 1 Pascal is equals to 1 Newton per square meter, and Newton is a unit of force here in the numerator F, and A, the square meter, is the surface area here. That's why the unit is Newton per meter squared, but most of the times we don't mention the Newton per square meter. That is only for the purpose of the conversion and solving of problems in the conversions. Okay, but we know as engineers and engineering students, we know really exactly that 1 Newton per square meter is equal to 101,325 Pascal, or just 1 Pascal at all. Because 1 man shot. Okay? it matters on the figure. Okay, but what I mean, 1 Pascal is equal to 1 Newton per square meter. If I will say also 101,325 Pascal, I will say also 101,325 Newton per meter square. Diba? Ganon. Oh. So, muna na siyang pressure. Mo ni siya akong gitudlo ninyo, guys, because our next problem is all about the relation of density and the pressure. Oh, diba? Okay, question number 2. Asa naman to, 8 minutes ako, guys. Okay, calculate the density of oxygen gas at standard temperature and pressure. Ganon. Calculate. You know, the sentence is very simple, but it requires you to think. You know, there are sometimes like that. The questions are very simple, but then it's very difficult to solve. And sometimes also, the questions are very difficult. It looks like so many given, and then it's very easy to solve. Okay, because there's a lot of decorations only. Okay, decorations meaning are only used at this certain quantity. This is the value, and then when you substitute in the formulas, it's no longer needed at all. You get the point? Oh, diba? Mga ganun siya kachuchok. Okay, calculate the density of oxygen. Charot. Okay, calculate the density of oxygen. Okay. Kaning density, guys, nagin na siya sa process, guys, ha? Kaya all liquids, solids, and gas has its own density. Then if the density is too much, then of course your vessels will burst. Okay, it cannot compensate to the stability of the container, and it will break Okay, like like this because the pressure is too high, and then it can no longer hold. That's why you need to know the density. You get the point? It has to do something with the molecular mass, molecular weight, and the mass also. Okay? So that's why we need to understand that during the design stage. Okay, ganon. So calculate the density of oxygen gas. Nakakaloka. Charot. Oxygen gas. What that? At standard temperature and pressure. At standard. So in chemistry or in physics, this is STP. Capital S, capital T, capital P, right? Oh, ganun siya. Really. Okay? Standard temperature and pressure. In ideal gas law, guys, the standard temperature is 0 degrees Celsius or 273 Kelvin. But take note, in physical chemistry, let's try to do this because so that we will not be confused. Because in physical chemistry, dealing with the standard values of the electron volts of different elements, okay, the reduction potential of different elements, that is at 25 degrees Celsius, the standard there. And also in the thermodynamic properties, 25 degrees Celsius also. And also in the enthalpy heat of formation and enthalpy of heat of formation of various elemental constituents, the standard temperature there is 25 degrees Celsius. So be careful also. This standard temperature is only for ideality of the gas. We should not mix up, okay, with other topic. Focus lagi ta sa ideal gas na zero yung standard because the other topics are 25 degrees Celsius. And in fact, the density of water is another also reference. It's the standard temperature there is not 0. It's not 25, but it's 4 degrees Celsius based on the experimental analysis. That's why they obtain 1 gram per ml, 62.43 pounds per cubic foot, and then 1,000 kilogram per cubic meter. So we will be confused na. Sir Sotero, there's a lot of references. Yes, of course. Due to experimental evidences, data analysis in the laboratory by the different chemists and physicists a long time ago. 17th century, 18th century, like that. Okay? Di gid siya permanente ang standard temperature. You get the point? Okay, but for the pressure, it might be standard all the time, 1 atmosphere. Okay? Something like, there's no variation. Correct me if I'm wrong. Sa pressure part. Okay? Like that. So the pressure standard also in ideality of the gas, or ideal gas, is 1 atmosphere. Okay. Mo ni siya ang may tabo karon higayon na. Now, calculate the density. So density is equals to mass over volume. Right? Basically, siya sa elementary level. I think grade 6 or grade 5. Okay? Now, we can also correlate density also in the calculation of the pressure, right? Pressure is equals to the density times height. Okay? And pressure is equals to force over area. Okay? And there's a lot of pressure also can be computed through the relationship of the ideal gases. Ito nga P1 V1 equals to P2 V2. And there's a lot. It's up to you to manipulate if you understand well. This is only a guidance. Okay? The basic guidance of what to do. Okay now. So, density ang atong gipangitan inang higayon na. Okay, now, if we use this equation number 1, equation number 2, what comes on your brain cells, guys, when you solve a problem? I'm not really that good in problem solving, but it is just only a guidance because I really experienced this 20 years plus ago in my age. I found out that it's gonna be like this. This is not really pala complicated that much. Our mentality and our perspective that we're really afraid and have the fear that we cannot solve it. Something like that. Mentality. Okay? So we should be positive all the time and confident. Oh, I can make this. Ganon. Okay, that add also a good factor to pass several examinations. Not limited only to board examinations. Okay? Like that. Now, we have the equation number 2. The density and the height. Be sure that in your formula use, it will not add complexity. First, go to the formula that is most simplified. Okay? Easy to understand, easy to manipulate, easy to understand, easy to remember first. And then if you don't have any choice, then go to the more complex, like, of course you don't have choice anymore. You get the point? But if you have still choices, go to the most simplest form, simplest formula, simplest quantity, simplified na talaga para di ka maglibog. Okay, ganon. Okay, so equation number 3. Now, density is being asked here. And then, if you use equation 1, it needs mass. It needs volume. So, there's two unknown. So, lisod. Oh, ikis. Okay. Equation number 2. Density times height. Ang pressure. Okay? And then, density will be equal to pressure over the height. You will manipulate through algebra, right? So, okay, pressure, but you don't have the height. Because there's no standard height. It's always standard temperature and pressure. So, okay, let's consider that as an option. Because one unknown lang naman siya, kaya may pressure. Okay, option number 1. Ganon. Okay, option number 3. Pressure is equal to force over area. Okay, it's more complicated because there's no density involved here. Okay, it's pressure, it's force of area, and you have to compute the dimension. Nakakaloka. There's no dimension of the device here. So the more it will be ikis. Okay, so what left is the second option, which is density is equal to pressure. Let's consider this. So density, ganun siya ha. Mag-jot down kag mga formulas na fit jud yun. Okay, so density is equals to pressure over height. Option number 1. Ganon. Now, maglabad man akong ulo, it creates me headache of the height of the elevation. It's okay if I'm just only measuring the blood pressure because the height of the mercury level on the blood pressure device is very easy to detect. There's a measurement. And we know the density of the mercury because we know also the density of water at 4 degrees Celsius. Okay, so density of a substance, okay, ganon siya, di ba? Because the density of the water, density of the liquid, ganon siya. Okay, so specific gravity, density of water over the density of a substance. Ganon, di ba? You remember this one? So, dali na kayo pagkuha nimo sa density of a substance if we get the density of mercury. Okay, so you need to know the specific gravity. Since this is in equilibrium, it's assuming that the density of water will always equal also to the density of the mercury. That's because they are inside the bulb, equilibrium. So the equilibrium pressure will be attained. So meaning to say, the pressure of the water, it will be equal to the pressure of the mercury. Now, it's very easy to compute for the blood pressure already. Okay? Or, look directly the measurement of the device manually in your eyes. You can see the pressure in mmHg. Okay? So this is the option number 1. Option mangita tag option nga dali ra jud kaayo. Since this is STP and ideality of a gas, then use the PV and RT. It looks like complicated, but when you manipulate this, it will become simplified. Why I use this? Because STP is always the ideal gas being used. Meaning to say, 1 mole of an ideal gas, okay, will occupy 22.414 liter of a gas, always. Something, that's the theory behind, so that we can get the volume, something at STP. Correct me if I'm wrong, if it is 22.414 liter or 24.4, but I guess it's 22.414 based on my memorization. Then, if I say, oh, I'm not really sure, then compute that again in this equation. You can get this, if it is 22 or if it is 24, then you derive the formula like that. Because I memorized it, so it's easy. Okay, but maybe my memorization will fail. That's why we need to prove that in the derivation here. Okay? But we don't do that because it will add time. Nakakaloka. Okay, now, so density. So calculate the density. Di lang ko aning option 1 ako nasa nang iikes because I will be confused with the height. Okay, but because this one doesn't involve height. There's no container, there's no medium, there's no pipeline, whatever. So it's just saying calculate the density of oxygen gas at STP. There's no such, reference or let's say the container being considered, something like that, or equipment being considered. So I will just remove this. So my last option will be the PV and RT. Okay, because this is ideal. My purpose of the discussion is just showing to you that there are possibilities how to solve this kind of problem. That there are a lot of problems with the same related formulas that has also the possibility to be used. That's only my main point why I incorporate this kind of possibilities to be used. Okay? So, others will interpret malibog sila, but I'm always telling this as an additional references, possibilities ba? Okay, ganon. So, with the good mo direct kada yun sa PV and RT. Okay, so PV is equals to nRT. Like that. Okay, so ganon. In this equation, guys, it's obviously there's no density. That's your first question. And the density is being asked. And then manipulate that through breaking down the formulas in each quantity involved in this ideal gas law equation. Ganon. So, you are not concerned with the pressure because we have already the pressure as 1 atmosphere. Check. Volume, we don't have the volume, so let's put X. And the more we don't have the N. Okay, let's have the 1 mole of N. If we treat this already as a 1 mole of an N in ideal gas law, then we cannot compute already the density because we assume already 1 mole. So we need to break that out. Why? Because in density, guys, it's directly proportional to the molecular weight. And the molecular weight also is directly proportional to the number of moles, which is the letter N in the PV in RT. Then if we try to put 1 directly, so walay hustisya. We cannot solve the density at all. Get the point? That's why we need to break this N. Okay, this is from the molar mass equal to the mass over the number of moles. Then this is mass over the molecular weight. Okay, then carry again the pressure times volume is equal to the mass times the molecular weight times the universal gas constant R times T. The R and the T, no question at all. Because temperature is always 273 Kelvin at standard temperature. Check. R, no question at all. You will memorize only at least 2 universal gas constant, okay? In your entire, let's say you take chemical engineering, in your entire first year to 5 years, just memorize only 2. Okay, 0.08205 liter atmosphere per mole Kelvin, or the other one, 8.314 joules per mole Kelvin. Enough. Because the others will be playing in the conversion and you can get still the universal gas constant value. So, and then take note the compatibility issue also so that it can cancel chupa-chucho. Okay, now, in his equation, guys, okay, akong break a number of moles. There's still no density, right? Okay, but there's volume. What's the formula of volume? Density is equals to mass over volume, right? Okay. Now, how can we arrive for this volume, Sir Sotero? Now, the mass and the volume is already present in the ideal gas law. They play around. Play, manipulate. Okay? So, if I will manipulate that one, the mass will be in the numerator, the volume will be in the denominator. So, it's gonna be like that. Okay? The mass in the numerator and the volume in the denominator. So, divide this entire quantity with volume. This is all about math na talaga siya, ha? Math. Sa katong mga algebraic expression na makancel-cancel ka, chupa-chucho, or quantities, duwa ba? Okay, now, so, divide this with V, and divide also this with V, right? Ganun chupa-chucho. Okay, V. Now, cancel the V, what we left is the pressure. Okay, then you cannot cancel the V here because there's no another V in the other side. Now, manipulate the crisscross multiplication again in algebra, math. Crisscross, diagonal on the right, diagonal on the left, so like, ganon. So it will become now pressure times volume. Okay, pressure times volume. Okay, then M mass over molecular weight times RT. O ganon. Nakakaloka. Okay. Now, mass over volume. So, density na siya. Okay. So, ganon mo na siya. So, over volume. Cancel naman na siya. So, mahitabo ang density mo. Mutong nga nagkalit. Makancel na ng V. So, you will say, guys, na kung i-manipulate mo siya sa algebra gihapon. Okay, volume. Unsa mo to what is the rule in algebra? Okay? Sa katuman ng indas, PM das, di ba? Mag-start kang parenthesis, then after that, multiplication, and after that, division, and after that, addition, and after that, subtraction. This is the PM das rule in algebra. Okay? Di ka magpataka. Kailangan na siya sequence. Okay? PM das rule. Okay? Imo to siyang gamitin chupa-chucho. Now, so since kani siya, dako man kayo siya ngayon ganito. O, di ba? It will become 1 over V. So, ano di ka? Pressure, okay, is equal to molecular mass over molecular weight, RT, kay V over 1 man na siya, ibalitok mo na nimo siya kung i-times, di ba? So, 1 over V na siya. Okay, kani siya expression na ari. No, 1 over V. So, ito na become pressure is equal to mass over volume. Okay, mass over volume, then RT molecular weight. Ganon. So, density na siya, ang M over V. So, density, substitute na din mag-density, anang higayuna. So, RT molecular weight, around. So, crisscross again. So, pressure is equal to molecular weight over density times RT, then density is equal to pressure times molecular weight over RT. Okay, ganun siya. Ang may tabunin higayuna. Okay, density RT nun siya. So, RT. So, our formula now, density, papasok na din na ito. Nakakaloka. Okay, guys. Density is equal to pressure times molecular weight times universal gas constant times T. Now, evaluate again. To make it sure that our derivation of formula is correct, take the unit of measure of density. And then we play around. Adjust. Maybe we are going wrong with our crisscross like this because we are not perfect as a human being. Okay, now we need to get the unit. Okay, the unit is, okay, let's do this. The unit of density, a lot. But in case of here, there's a liter and there's a gram. So understood to be grams per liter. Right? So grams per liter. What's your connection ng ml, Dre? Kung may ml. Okay? You got the point. And grams na ay connection because the unit of molecular weight is grams per gram mole. So na grams. So let's prove this that the unit will be grams over per liter by checking this formula. Maybe this is wrong or reverse or whatever chuba-chucho. Now, let's substitute values muna ha. Compatibility. So, we have pressure, atmosphere, right? Molecular weight, grams per gram mole. Okay? Universal gas constant, liter, atmosphere, mole, Kelvin, right? And then multiply by Kelvin. Okay, cancel Kelvin, cancel Kelvin. Okay, mole, cancel. And then atmosphere cancel. Yes, grams per liter is the unit. This is correct. My derivation is correct. Because I obtained grams per liter in validating the logical arrived formula in my derivation. Ganon. Okay, this is correct already. Now, makasolve na ka sa density. Because density is equals to pressure times molecular weight over universal gas constant times the pressure. O, check. Kay 1 atmosphere. O, ganon. Substitute ko 1 atmosphere. Ganon. Tagsa-tagsaon. And then, molecular weight. O, take note the molecular weight of oxygen. Okay? Oxygen, like this, has a mass number of 16. Oh, sorry. 8. O, 16. Then 2. Okay, ganon. So, oxygen is 32, right? Correct me if I'm wrong. Oxygen, guys. Okay, let's review the oxygen. I did not memorize completely. Okay, this is a negative 2 ang charge. Okay, and 2 times 16, like 32, right? Okay, like that. So, wait. I forgot to memorize the oxygen. That's common. I think it's 8 only. Sorry. Sorry, guys. Huna do. Okay, oxygen. Okay, the mass number is 8. Okay, and the atomic number is 2, and the charge is negative 2. And then, 2 times 8 is equals to 16, right? 16 is the molecular weight. Okay, ganon. Grams per gram mole. Sorry guys ha. Okay, just like nitrogen, akong gitimanan ang nitrogen, guys. Ana ba ang nitrogen? Ana na guys ako makalimot gani ka guys, mag-comparative study dayon ka. Tapos ako makalimot mo ko sa oxygen karon ganyan na. Hala, naglibog ko. Ana, di naman ko nibalaan nga uban na nitrogen na nakabaw ko nga N7 yang 7 yang mas number, 2 ang sa ubos. Nya, klaro kayo ngayong ano sa nako. Mo na siyang na-sure nako nga 16 ang iyang grams per gram mol. Sometimes things like that also ha. Okay, not only memorization, but you should also analyze comparative analysis or comparative study so that it helps you to remember. So, daga siyang para-paraan lang talaga yan. Okay, ganon. Okay. Tungkol sa kasayo nakalimot. Okay, nakakaloka. So, 1 atmosphere molecular weight of oxygen is 16, right? Grams per gram. I remember also, 32 is for sulfur. Okay? Sulfur. Right? And then, universal gas constant, 0.08206 liter atmosphere mole per Kelvin. Oh, ganon. And then Kelvin is 273. Okay, cancel Kelvin, mole, cancel mole, and then liter, atmosphere, and grams will remain. Okay, ganon. And now let's check also, guys. See, I use 16. Di ba chupo kontento anang gayon na? Ako sila ma-prove sa answer sa density. Right? But later na lang siya. Kasi correct na itsure. Sarap. Okay. 7.0. Ganang-ganang chupa-chuchu. Ano makaloka? 0.08206 times 273. Chupa-chuchu. Okay. 22.41. Wow. I think this is correct. I remember. Okay? Kini upper day ng volume. Diba? Mamaya ang standard sa volume gas, guys, at ideal gas law. Okay? So, liter. And then, 16 times 1, grams. Then, 1. Pila na siya. Okay? Ano daw ba 16 times 1, 16 times 1, okay, divided by 22.414. 0.71. 0.71 grams per liter of oxygen. Now, you will analyze also, if that is the case, grams per liter, convert that to grams per ml na, para lang ma-relate mo sa water. Okay, guys? Because I am not really sure if I am using the correct molecular weight, manggod. Okay? But I'm pretty sure it's correct already, right? But let's just prove it again. Okay. If I have the density of water, oxygen gas of 0.71 grams per liter, oxygen gas, since we know the density of water is 1 grams per ml, right? Convert this into liters, grams per liters also for water. So this will become 1000 ml and then 1 liter. Cancels, and then 1000. So it will become also 1000 grams per liter. Okay. Now, compared to 0.71 sa O2. Why too much? Because liquid is heavier than a gas. Right? That's the concept behind. That's why it's very big. Okay, now, if I have a chemical reaction, kaloka, chemical reaction, suro na dyan ako, okay, well, imagination lagi. Okay, so H2 plus O2 is equals to water, right? And then we have the density of water now, 1000 grams per liter. And I have the oxygen, which is 0.71. Okay, 71 grams per liter. Now, in mathematics, if both are having the same unit, we can add that immediately, right? If you can remember. So, we let X as the density of hydrogen gas. Okay? Kaloka naman ganito. Okay? So, solve for the value of the density or the X of H2. X equals to 1000. Kaloka? Nabingani? 71 is equals to something chuba-chuchu. Or take note. This is liter, right? And in ideal gas law, it will occupy 22.4 liter man siya. So we can multiply this by 22.414 also. Cancel para mahimong grams. Okay, kaya ideal na natin isgutan, guys. Okay? Okay, para sure ta kay it looks like very awkward to add density. Okay ba? Kung mag-add tag duha ka density, mahimong palitan. Yung ko nga, density of mercury, 2 grams per liter. I-add mo ang duha ka density, pwede ba siya? Because there's 2 already, 2 units already, di ba? The grams and the liter. I doubt it's not right. Really, it will be applicable only for 1 unit. So, mass like this, liters like I think. So that's why we need to break this one, ha? Okay? Himola ni nato siyang grams gyud para sure. Okay? So, density of oxygen. Okay? This is the density of oxygen, right? Density, mass over volume. Okay? So this is an ideal gas, then compute for the mass. Mass is equal to 0.71 grams per liter of oxygen times the volume of 22.414 liter, because this is an ideal. Cancel. So how much is our mass? Nakakaloka. So 22.414 times 0.71. Our mass is 15.91. So 15.91 grams for oxygen. 15.91 grams. And then what is the grams of H2 to be added? Now convert also the 1000 grams per liter. So 1000 grams per liter times 22.414 liter. Cancel, chupa. Okay, 1000 times 22.414 is equals to, nakakaloka. 22,414. So 22,414 grams. Okay, ang imong water. Ganon. Okay. Now compute for the mass of hydrogen. Mass of hydrogen is equal to 22,414 minus 15.91 grams. So, mali mong answer. Okay, minus 15.91. Ganon. So, 22,398.09. This is gram per liter. Now, since you have this one, okay, that's too big, right? 22,391 grams per liter of H. Okay, and you have here, this is mass pa. Sorry, mass pa siya. It's okay. Okay. May buong lang ko kaya. Bin akong density, taas tayo. Okay, so grams. Okay? So, possible siya, guys, right? So, 22,309 grams. Ganon. Now, naman kay density, okay, mo na i-manipulate into grams per liter na 1,000. Okay. And grams naman na siya na nangigayon na. So, i-divide din mo siya 22.4 liter. Okay, divide na mo siya. Charala. Divided by 22.414 liter. Okay, 1,000. Himo sa siyang 1,000 ang yung density. So, it's correct. Okay? 1,000 man grams per liter ang density sa water. O, diba? Ganon. So, ang answer niya, guys, mo to siya. Ako yung papas. Okay, basta mo na to kung naminaw maka mo. Okay, 1.43 grams per liter. Okay? Like that. You get the point? Ganun. PVNRT lang siya. Okay? Okay, you get the point? So that's very, very clear. So, muna siya ang pag-compute sa density, the mass, something like that. Oh, hey, Carol. Jun Carol, kaya kainin mo, guys. Kaya kainin mo dong. Okay? Muna siya. So, salamat kayo sa inyong pagtanaw ninyo gayon na the density and the relation with the pressure. Okay? So, mo gina siyempre may kuan. Kung mag-engineer mo gina yung mga timanan, ha? Okay. Ano, pagduha-duha. Wow. Talaga. Especially kung ma-assign mo sa mga design. Okay? Like that. Okay. And a lot of calculation, mga integral calculus. Calculus, differential calculus. Okay? And differential equations, ganyan. Okay?